Hello dear students, welcome to the lecture on calculus and linear algebra. In this lecture video, I am going to discuss about the Gauss elimination method. So here, we'll discuss briefly about how to perform the Gauss elimination method and also the problems based on the Gauss elimination method. So first we will see why to perform Gauss elimination method and how to perform the Gauss elimination method. So for that I am going to consider a system of three independent equations in terms of three unknowns, that is x1, x2, x3. So the system is given like this: a11 x1, a12 x2 plus a13 x3 is equal to b1, a21 x1 plus a22 x2 plus a23 x3 is equal to b2, a31 x1 plus a32 x2 plus a33 x3 is equal to b3. So from this system of equation I am going to make this system in terms of matrix form, that is ax is equal to b form. So where a will be a coefficient matrix and x and b will be a column matrix. So now we'll see how to get the coefficient matrix a, x as well as b. So now from the previous system of equation I can get the matrix A is equal to a11, a12, a13, a21, a22, a23, a31, a32, a33. X will be equal to x1, x2, x3. B is equal to b1, b2, b3. So now the aim is to get an upper triangle matrix by framing the augmented matrix here. So now the first thing is I am going to frame the augmented matrix. So after framing the augmented matrix, I am going to perform series of elementary row transformation, the main thing to get an upper triangle matrix. So upper triangle matrix in the sense below the main diagonal entries, the elements must be 0 here. So in this augmented matrix we can see here, so we have to make this a21, a31, a32 as 0 to get an upper triangle matrix by using elementary row transformation. So now the first thing is I am going to make an augmented matrix A and B here. So this A and B is given by a11, a12, a13 is b1, a21, a22, a23, b2, a31, a32, a33, b3. So now the first thing is I can make only a21, a31 0 in the first step. So in the step 1, I am going to convert a21 as 0, a31 as 0. I mean the first entries of all 2 row or 3 row is 0 in the above augmented matrix. So by using elementary row transformation. So after applying the elementary row transformation to make the first entries of R2 and R3 0, I got the matrix like A11, A12, A13, B1, 0, A22 dash, A23 dash, B2 dash, 0, A32 dash, A33 dash, B3 dash. Because these all entries are here now new entries after performing the elementary row transformation. So now the next thing is I want to convert this A32 dash also 0. So that I can get the upper triangle matrix there. So now what I can do? So now I'm going to perform the next step to make a next entry as 0. So in the step 2, I'm going to make the A32 dash is 0 by using elementary row transformation. So after applying the elementary row transformation only for R3 row, I'll be getting the matrix like A11, A12, A13 is equal to B1, 0, A22 dash, A23 dash, B2 dash. Third row will change now completely because I am applying the elementary row transformation only for third row. 0, 0, A33 double dash, B3 double dash I will get it. So here these are the new entries after the transformation. So now we got a upper triangle matrix. Now from the system we have to identify the values of x1, x2, x3. So now for the system of equation I am going to multiply the column matrix x1, x2, x3 to get a system like this. So now from the above matrix the system of linear equations can be equal to the system of the following equations like a11 x1, a12 x2, a13 x3 is equal to b1, a2 dash x2 plus a23 dash x3 is equal to b2 dash, a33 dash x3 is equal to b3 double dash. So now from the system we can easily find the values of x3, x2 as well as x1. So from the third equation we can easily estimate the value of x3. So after finding the value of x3, I am going to replace this x3 value here so that I can find the value of x2 there. So after finding this x2 value and x3 value, I can replace both the values in the first equation so that I can find the value of x1 also. So we'll see some examples based on the Gauss elimination method. So the following system of equations by using Gauss elimination method. The system is given like x plus y plus z is equal to 9. x minus 2y plus 3z is equal to 8, 2x plus y minus z is equal to 3. So the first thing is what? We have to make a matrix equation like Ax is equal to B form. So from that separate A, X as well as B. So what we can find, the matrix A will be 1, 1, 1, 1 minus 2. I'm going to draw now. So after separating the matrix, I'll be getting the matrix like this: 1, 1, 1, 1 minus 2, 3, 2, 1 minus n. This will be our A matrix. So X will be same, that is in terms of X, Y, Z is equal to B matrix, that is 9, 8, 3. So this is the matrix representation of the given system of equations. So now what we can do, I am going to frame the augmented matrix now. So let me frame an augmented matrix after getting the system of equation Ax is equal to B. So now the augmented matrix will be about 1, 1, 1, 9, 1 minus 2, 3, 8, 2, 1 minus 1, 3. So now let me take the first one as R1 row. This is row R1, R2, R3. So now I'm going to apply the series of row transformation. So now the first thing is what? I want to make the first entries of R2 row and R3 row as 0. So what I can do? I can do the operation like for R2. R2 implies R2 minus R1. R3 implies R3 minus 2R1. I can do it. So after applying this series of row transformation, we can see here. So the first row is no change. I'm keeping as it is 1, 1, 1, 9. I'm doing the operation with respect to only R2 row. So subtracting R2 with R1, I'll be getting what? 0. Minus 2 minus 1 will be equal to minus 3. 3 minus 1 will be equal to 2. 8 minus 9 will be equal to minus 1. Right? Next is R3. So R3 implies R3 minus 2R1. So 2 minus will be equal to 0. 1 minus 2 will be equal to minus 1. Minus 1 minus 2 will be equal to minus 3. 3 minus 21 will be equal to minus 3 minus 18 will be equal to minus 15. So now I want to make the this entry also will be equal to 0. I want to convert this minus 1 as 0 here. So what I can do, the operation will be like R3 implies that, or we can do like this also. R3 implies that 3R3 minus R2 I can make it. Right? 3R3, I'm doing operation like this, 3R3, subtracting this row, 3R3 minus R2. So what I can get? 1, 1, 1, 9, 0 minus 3, 2 minus 1 as it is. So it will become anyway 0 only, because both are zeros here, 0. So it will become obviously 0 only. So now it will become minus 9, minus 9 minus 2, it will be equal to minus 11. Next is, so same thing here also, I'll be getting 44. So now we go to upper triangle matrix. So now for this system of equation, I'm going to multiply the column matrix XYZ to get a new system of equation to find the values of XYZ. So what I can get here? I'll be getting X plus Y plus Z is equal to 9, minus 3Y plus 2Z, 2Z is equal to minus 1, plus 11Z is equal to 44. So from this equation, I can get Z is equal to 4. So after finding Z value, I can replace this Z value here to find the value of Y. So I'll be getting minus 3Y plus 8 is equal to minus 1, or Y will be equal to 3. So after finding Y and Z, I'm going to replace this in the first equation to find the value of X will be equal to 2. So therefore, the exact values of X, Y, Z is 2, 3 as well as 4. Next example, apply Gauss elimination method to solve the system of equations 2x plus 5y plus 7z is equal to 52, 2x plus y minus z is equal to 0, x plus 5 plus z is equal to 9. So now same thing again. So from this we have to frame the what is that system of equation, that is Ax is equal to B form. We have to get it. So let me frame that. So the matrix A will be what? 2, 5, 7, 2, 1, minus 5, 1, 1, 1. And the column matrix X will be X, Y, Z is equal to B matrix, that is 52, 0, 9. This is a matrix form of the given system of equations. X is equal to B. So now what we can do, I want to frame the augmented matrix to get a upper triangular matrix by performing the series of Elementor transformation. So now the augmented matrix will be of the form AB is equal to 1 1 1 9 2 1 minus 1 0 2 5 7 52. Because y means here, to perform the elementary row transformation, the first entry of the first row must contain the least value. So here 2 to 1 is the starting value. So I'm interchanging the row R2 with R3 with R1 row to make the operations very simpler. So now after making the augmented matrix, I want to convert the first entries of R2, R3 row 0. That is 2 2 I want to convert as 0. What I can make? I can make the operation like R2 implies R2 minus 2R1, R3 implies R3 minus 2R1. So what I will get? 119 as it is, 0 minus 1 minus 3 minus 18 for applying the transformation with respect to R2 with this condition. In R3 will be 0, 3, 5, 34 by applying the row transformation for R3 row. That is R3 implies R3 minus 2R1. So next is I want to make this 3 also 0. What I can do? The operation will be like R3 implies R3 plus 3R2. So I'll be getting what? 1, 1, 1, 9, 0 minus 1 minus 3 minus 18, 0, 0 minus 4 minus 20 I got it. So I got an upper triangle matrix now. So now for this upper triangle matrix, I'm going to multiply the column matrix x, y, z to find the new system of equations to find the exact values of x, y, z. So after performing the operation, I'll be getting the equation like x plus y plus z is equal to 9, minus y minus 3z is equal to minus 18, minus 4z is equal to minus 20. So after simplifying this, we'll be getting the value x is equal to 1, y is equal to 3, z is equal to 5 is the exact values of the given system of equations. Thank you.